Hello everyone. If you have been struggling with electrolysis, especially for the required practical, I've made a flowchart to help you decide what products you are going to make and a little bit about why. So at the top we have our electrolyte. That's our substance that is having the electricity pass through it. We then need to decide whether it is molten or if it's dissolved. If it's molten, we go this way, and then it's nice and straightforward. Our non-metal will be formed at our positive electrode, and our metal will be formed at our negative electrode. They won't give you anything else that could complicate that. If, on the other hand, it is dissolved, life becomes a lot more complicated. We need to look at the positive electrode and look at what our non-metal in our electrolyte is. If it's a halide, that means it's in group 7, then we'll make a halogen, so depending on what it is. If, on the other hand, it is not, then we will end up forming oxygen. Once we've done that, we need to have a look at our negative electrode, our cathode, and this is where we need to know a little bit of our reactivity series, because we need to know whether our metal is more or less reactive than hydrogen. If it is more reactive than hydrogen, then we will make hydrogen. If it is less reactive than hydrogen, then we'll make our metal. So, some examples. If we have a look at sodium chloride, you'll notice that this says a little L there, indicating that it is a liquid, meaning that it is molten. That is important. So, what that means is that, this should say sodium chloride molten. Because it's sodium chloride that is molten, it's just got all of those sodium ions free to flow about and those chloride ions free to move about. There's nothing else in there, so our life is nice and easy. That means we need to go that it is molten, so going across that way, and then we can look at our cathode and our anode at the same time. So we're making the metal and the non-metal. In this case, that means that it's sodium, because sodium was the metal in sodium chloride, and chlorine is formed because chlorine is chloride, the non-metal. If you're doing higher tier, we need to then have a look at what is going on. So at the negative electrode, our sodium ions are picking up negative electrons, and that is converting them from positive sodium ions into sodium atoms. If we remember oil rig, oxidation is loss, reduction is gain, that means that this has been reduced. On the other hand, if we have a look at our chlorine, well, because the electrons are on the other side, sorry, there should be a 2 there as well, because it's 2 electrons, we will form chlorine molecules, which is a gas. That's why we would see bubbles. And if we think of oil rig again, oxidation is loss. So because the electrons are on the right-hand side, that means that this has been oxidized. If we this time have a look at sodium chloride, which you'll note has a little AQ there, that is important, that means it's aqueous. That means that our sodium chloride solution is a little bit more complicated. Instead of just sodium ions and chloride ions, we've also got hydrogen ions and hydroxide ions. In here as well would be lots of water molecules, but I've not drawn those just because I'm interested in the ions specifically. So, our electrolyte is dissolved. That means that we've got hydrogen ions, sodium ions, chloride ions, and hydroxide ions. I'll look at the positive electrode first. Is the non-metal a halide? That's in group 7, so chlorine is in group 7. Yes, it is. So we're making chlorine gas. To test for that, we would use some damp universal indicator or litmus paper, and we would see that it gets bleached white. For the half equation, it is exactly the same, and I made exactly the same mistake here, is that we're taking our chloride ions, converting them into chlorine gas, and that means that because we've got our electrons on the right-hand side being formed, our chloride ions have lost them, so it has been oxidized, because oxidation is loss of electrons. If we move on, we would have a look at our negative electrode, and we would need to decide, is the metal more reactive than hydrogen or not? Sodium is way more reactive, it's one of the most reactive metals that we deal with. That means that we will produce hydrogen. And what's happening here is that the hydrogen, and I've been very bad about not putting in the 2's in front of that, is that our 2 hydrogen atoms will each gain an electron, turning them into hydrogen atoms instead of ions, making hydrogen gas. So we've made hydrogen. We do still have one thing to do. If you have a look up here, we have used the hydrogen ions, we've used the chloride ions. That means that we've got sodium ions left and hydroxide ions. That means that the solution that we're left with is those ions that we haven't used. So it's sodium ions, hydroxide ions, and that gives us a solution of sodium hydroxide. Okay. I've got another one for you, because I gather that some of you were struggling with what to do if it's not in group 7. So if it had a sulfate at the end, or a nitrate at the end, or anything other than iodide or chloride or bromide. Okay, so again, here we need to be nice and careful. It does say AQ, so that means that it is aqueous, and this would be something like what it would look like. So again, we've got our hydrogen ions floating around, we've got our hydroxide ions floating around. This time, and I was very naughty and I didn't update what I had at the top, this time we don't have sodium ions and chloride ions, we've got copper ions, and we've got sulfate ions, which are SO4 2 minus. Oh, no, I don't want to stop recording. So it's dissolved, so we're going to go the dissolved way. And we've got hydrogen ions, copper ions, sulfate ions, hydroxide ions. So we'll look at our anode, our positive electrode, and is the non-metal halide? Well, our answer is no here, so we're forming oxygen. What is happening here is it's not the sulfate ions that are reacting, it's actually those hydroxide ions. And we find that 4 hydroxide ions react to form 1 molecule of oxygen, 2 molecules of water, and releasing 4 electrons. Again, because the electrons are on the right-hand side, that means that these have lost them, so that means that this has been oxidized again. This equation is one that you would be best to just learn. Okay, it is possible to work it out, but it is a lot more complicated than any of the others. Once we've done that though, we need to have a look at our negative electrodes. We need to have a look at, is the metal more reactive than hydrogen? Copper is far less reactive than hydrogen, so it is going to be our copper ions that gain those electrons, becoming copper metal. That's why we see copper metal being deposited. And again, because our electrons are on the left-hand side, that's meaning we're adding them on, so our copper ions have been reduced. What we're left with, in this case, isn't really something that you'd be asked about, but for the sake of it, we will do so. We have our hydrogen ions floating around, we have our sulfate ions floating around, so we're going to end up making effectively some sulfuric acid left in our solution. I hope that is helpful. If you're not sitting higher tier, you don't need to know the half equations. If you are sitting higher tier, you do need to know those half equations. So I hope that has been helpful, and the